Welcome to our exploration of the impact of climate change on global energy demand and supply. In this video, we'll examine how shifting climate patterns are transforming energy needs across the globe, from increased cooling demands influenced by rising temperatures to changing energy use in agriculture. We'll delve into the implications for traditional fossil fuel supplies and the vulnerabilities faced by renewable energy sources, while also discussing the exciting potential for solar energy in a warming world. Join us as we unpack the challenges and opportunities presented by climate change for our energy infrastructure and overall sustainability efforts. 1. Energy demand. Climate change is dramatically influencing energy demand by altering consumption patterns across various sectors. As temperatures rise, the need for cooling solutions like air conditioning and refrigeration increases, especially in warmer climates. This surge in demand often puts a strain on power grids, particularly during the sweltering summer months. Conversely, the demand for heating may decrease as winters become milder, thus potentially lowering energy consumption in traditionally colder regions. However, the decline in heating needs is not uniform, as it varies based on regional heating technologies and behaviors. In agriculture, changing weather patterns necessitate more energy for irrigation and cooling, further escalating energy consumption. Urbanization and climate adaptation efforts introduce energy-intensive technologies, such as desalination for water and advanced cooling systems for public spaces, further driving up energy demand. 2. Increased cooling needs. With the mercury rising globally, the demand for cooling solutions is skyrocketing. People are increasingly relying on air conditioning to maintain comfort, especially in regions that experience prolonged heat waves. This growing dependence on cooling systems can lead to peak electricity demand during hot summer days. As the need for refrigeration also grows, particularly in food storage and transportation, the overall energy consumption for cooling purposes sees a significant uptick. This trend poses challenges as power grids may struggle to meet the heightened demand, leading to potential power shortages or increased energy costs. Furthermore, if cooling technologies are not energy efficient, they can exacerbate the very problem they aim to solve by increasing greenhouse gas emissions. 3. Decreased heating demand. As winters become less severe due to climate change, the demand for heating in colder regions is expected to decline. This shift can lead to reduced energy consumption in households and industries that rely heavily on heating during the colder months. However, the decline in heating demand is not uniform across the board. Different regions have varied heating technologies and habits, which means the impact may be more pronounced in some areas than others. Additionally, while overall heating needs may decrease, the unpredictability of weather patterns means that extreme cold spells may still occur, requiring efficient heating solutions. The challenge lies in balancing the reduced demand with the need for reliable heating during unexpected cold weather events. 4. Energy use in agriculture. Agriculture, one of the most energy-intensive sectors, is significantly impacted by climate change. Shifts in weather patterns, such as irregular rainfall and increased temperatures, necessitate more energy for irrigation and cooling in agricultural processes. Farmers may need to rely on water pumps and cooling systems to maintain crop yields, leading to increased energy consumption. Moreover, as certain crops become less viable in traditional growing regions due to climate changes, agricultural practices may shift, potentially requiring more energy-intensive methods. This increased energy use in agriculture can lead to higher operational costs for farmers, which may ultimately affect food prices and availability. 5. Urbanization and climate adaptation. Urbanization and climate adaptation efforts are driving changes in energy demand across cities worldwide. As urban areas expand, they face the challenge of adapting to extreme weather conditions, which often requires energy-intensive solutions. For instance, cities may invest in desalination plants to secure water supplies, a process that demands significant energy input. Public spaces and infrastructure may also need enhanced cooling systems to ensure comfort and safety during heat waves. These adaptations, while necessary for urban resilience, contribute to increased energy consumption. The challenge lies in implementing these solutions in an energy-efficient manner to minimize their carbon footprint while meeting the needs of growing urban populations. 6. Energy supply. Climate change presents both challenges and opportunities for energy production and supply. Fossil fuel power plants face reduced efficiency as temperatures rise, and extreme weather events can disrupt extraction, transportation, and refining processes. This vulnerability highlights the need for more resilient and adaptive energy systems. On the flip side, renewable energy sources like solar, wind, and hydropower are also affected by climate-sensitive factors. For instance, prolonged droughts can reduce hydropower generation, while extreme winds may damage wind turbines. Despite these challenges, some regions may experience increased potential for solar energy, as longer periods of sunlight enhance solar power generation capabilities. However, ensuring the resilience of energy infrastructure against extreme weather events remains a significant concern, as hurricanes, floods, and other natural disasters can damage power lines and pipelines, leading to supply disruptions and increased repair costs. 7. Impact on fossil fuels. The fossil fuel industry is particularly vulnerable to the effects of climate change. Rising temperatures can reduce the efficiency of power plants that rely on fossil fuels, leading to decreased energy output. Additionally, extreme weather events, such as hurricanes and floods, can disrupt the extraction and transportation of fossil fuels, causing supply chain interruptions. These challenges highlight the need for more resilient infrastructure and adaptive strategies in the fossil fuel sector. Furthermore, as the world shifts towards cleaner energy sources, the demand for fossil fuels may decline, prompting the industry to explore innovative solutions to remain relevant in a changing energy landscape. 8. Renewable energy vulnerability. Renewable energy sources, while essential for a sustainable future, are not immune to the impacts of climate change. Solar, wind, and hydropower rely heavily on climate-sensitive factors, making them vulnerable to extreme weather conditions. For instance, prolonged droughts can significantly reduce hydropower generation, while extreme winds may damage wind turbines. Solar energy, too, faces challenges as dust storms and cloud cover can diminish its effectiveness. These vulnerabilities underscore the importance of diversifying energy sources and investing in technologies that enhance the resilience of renewable energy systems. By doing so, the global community can ensure a stable and reliable energy supply even in the face of climate-related disruptions. 9. Increased potential for solar energy. Despite the challenges posed by climate change, solar energy presents a silver lining. In some regions, longer periods of sunlight due to shifting climate patterns can enhance the potential for solar power generation. This increased solar exposure offers a valuable opportunity to harness clean energy and reduce reliance on fossil fuels. As technology advances, solar panels become more efficient, allowing for greater energy capture even in less than ideal conditions. Harnessing this potential requires strategic investment in solar infrastructure, including the development of efficient storage solutions to manage energy supply during cloudy or nighttime periods. By capitalizing on the increased potential for solar energy, societies can take a significant step towards a more sustainable and resilient energy future. 10. Energy infrastructure resilience. A virus capable of wiping out a significant portion of the human population could lead to social and economic collapse. Such an event would disrupt healthcare systems, food production, infrastructure, and governance. The resulting chaos could lead to widespread anarchy and a breakdown of societal structures. The potential for global disruption underscores the importance of preparedness and resilience in the face of viral threats.